So once you're trying to find your seats, I'd like to tell you that actually it's my first time on GeeCON as a speaker, and it's a 10th anniversary. And this is a really great feeling to be here. My name is Grzegorz. I'm a system engineer at Casumo on Malta, mostly remotely, and a trainer at Bottega IT Minds. Other than this, I write some blogs and contribute a bit to open source. And today we'll be revising some ideas known from the world of functional programming. But this time we'll focus specifically on exceptions from a few different perspectives. At the beginning we'll rant a bit around exceptions, exception handling, especially in Java. Then we'll remind about a few ideas known from type-driven development, and then we'll jump straight into details and see how those ideas can be implemented in your everyday job by leveraging abstractions like optional, try, or eithers. So, quite a long time ago, people started noticing that there is something fishy with the way we handle exceptions, that those unexpected jumps bypassing normal standard program flow can be very deceiving. I mean, if you want to build applications that you can rely on. So, for example, like one of the first mentions of that you can find around 2003 from a blog post by Joel Spolsky. By the way, Spolsky is a surname. It's Spolsky. It doesn't mean he's from Poland. It's Spolsky. A small disclaimer, if you don't know Polish, Spolsky literally means from Poland. So, the whole rant about exceptions started with criticizing them, that they create unexpected exit points from methods, that they behave kind of like go-tos because of the whole try and catch thing. Other than this, those roads that are created, they are invisible in source code. They are hard to follow because it's often quite hard. You can't just control-click and find all handlers that you need. Of course, if you are playing with asynchronous programming, that also can be problematic because, well, you can simply lose stack traces being printed out. What's actually quite interesting is that exceptions don't come for free. Imagine you would like to design your own exception type. And you might think that's something like a POJA. But there's something about that that it's much more costly to instantiate than any other POJA. Do you have any idea what this could be? Exactly, stack trace. So usually at this point I would give you a prize, but I don't have any prizes, so just accept my token of appreciation. Yes, it turns out that there is a method, fill-in stack trace, in the throwable class that's very costly to call. So basically, any time we create an exception, we need to just pretty much run through all frames in the stack to collect the whole call history. And this is super expensive. Actually, you can read more about that in this very nice blog post from Heinz Kabutz. But there's also one very interesting write-up about it from Norman Meurer. You might know him from netty project, where he's the main contributor for many years. So, since netty focuses on performance as much as possible, they started experimenting what they could do with exceptions, since they are quite costly to instantiate. So Norman started experimenting with benchmarks at the beginning. So he created 3 different scenarios. First, included pretty much creating exceptions and throwing them. Second one included creating exceptions, caching them, and leveraging those instances in any future, in the same situations. And the third one, the most extreme optimization, included creating one single static exception without a stack, so that you don't pay the cost of collecting all stack frames. And this is actually quite fine, because if you are throwing an exception, one dedicated exception in one particular scenario, you might not really need all those additional information. And here are the results. So we have 3 groups of exceptions, 3 groups here that you can compare, and the results are in operations per millisecond. So what you can see here is that On the left, you have bars there. They are very small, they are very hard to see, but they are there. And those represent situations where normal exceptions were instantiated in thrown. And as you can see, there is much less than one operation per unit of time. And on the right side, you have this situation where they were having, when he was reusing a static instance of a stackless exception. So as you can see, the difference is huge. On the right side, you have over 60 operations per unit of time, and on the left, you have way less than a single one. So that's about it when it comes to hating exceptions in Java. So how other languages managed to approach this thing? So a very cool approach was used in Go. Go created a very distinct difference between what's an exception and what's an error. So exception in Go is something that you don't expect people to recover from. And errors is, well, all those values that can be returned from methods but are not critical for your application. So what's happening right there? Whenever you are calling some method, you have two values that can be returned or more. So you get the actual value that you care about and an error. So exception handling in Go is pretty much as easy as doing a null check. But wait, you promised us a very cool functional exception handling, and now you are showing us null checks? Yes, that doesn't look super perfect, but we can let's try appreciate how simple is this. Okay, whenever there is some error happening in your method call, it's returned via a second value from your method, and now there is no bypassing any program flow. You just need to check if this value exists or not, and you can act upon it, and that's all. No magic involved. But obviously, there are scenarios where actually you don't want people to recover from that. And Go has a very specific keyword from that. This is called the panic. So whenever you are in a panic mode, well, it's done. Well, technically, you can recover from that, but it's designed to notify users that, well, that it's fine if you don't. And this time, meanwhile, in Java, people are trying to identify as many bad practices related to exception handling as possible. And there's quite many of them. Of course, everything depends on the context. And now it's not the point to just go through all of them and start bashing Java, but it's good to be aware that the exception handling mechanism that it's there, it caused a lot of ambiguities that are unresolved. So, what can we do about this? So first, before we jump into the actual content, let's revise our knowledge about statically and dynamically typed languages. So actually, we are here on a conference, on a Java conference, so I think I don't need to convince you that much to use static typing. But let's recall why this is actually very beneficial for us. So as you can see, the difference between static and dynamic is that in dynamic, the abstraction of types don't exist. You can add methods in runtime to types, you can convert them, and so on and so on. And in static, once you instantiate your object, it sticks to this type as long as possible. But recently, for example, this has been criticized a lot. For example, by Uncle Bob. He wrote a post bashing Kotlin and Swift for being too statically typed because it enforces too much bureaucracy. There's so much bureaucracy, and in his perfect world, everything would be dynamically typed, and then we would have tests for everything to cover. So instead of doing static typing, you can go for dynamic approach and create sets of tests that enforce certain things that would be enforced by static typing. And actually, a few days before this conference, one tweet went a bit viral. So one guy was a bit of complaining that why does he need to write all those tests? Why some library can't do this? And Mario Furskor, well, responded with explanation that, hey, maybe you should try static typing because this is what it does. Well, the tweet went quite viral for a while, so poor guy got discouraged from asking questions on Twitter again. So, while we are here, there is some truth in that, okay? Because we can replace all of that with tests, but will we do that? I mean, in all projects I've seen, we never had basically proper testing. I mean, we had testing, but never coverage wouldn't be ever like 100% satisfactory. And if you remember the first, in the Agile Manifesto, the biggest value introduced by that is that by introducing smaller iteration cycles, we can adapt much quicker to changes. So if your tests, you need to run your tests manually, and if they run for quite a long time, you are not likely to run them. Okay, if your tests, how often do you run your tests if they run for 30 minutes? But if you leverage properly the power of static typing and type-driven development, you have this feedback cycle continuously. Okay, whenever you try to assign an int to a string, you get a compilation error, and I think this is something worth leveraging. But on the other side, if you don't compile your code, you don't get compile time errors, right? So, but if you actually want to leverage static typing in a proper way, well, it requires some effort. So if you're working with JavaScript, for example, it's dynamically typed, and well, you don't write types, and you leverage that, and you're happy. But here, in a statically typed world, if you want to leverage the power of that, well, there needs to be some effort. So you need to construct this like type safe tree stronghold for yourself. But here, it's an effort, okay? So we are quite often what I see is that people just stringify everything. But if you wanted really to like leverage that, you would create your domain, wrap them in your own types to give those values some new semantic meaning. Because, every name is a string, every surname is a string, but not every name is a surname. So at the end of the day, it can save us a lot of problems. In one of the last projects we did, we decided to try to wrap all like database IDs into their own classes. So we wouldn't just pass longs around; those would be simply just client ID, product ID, whatever. And it saved us actually quite a lot of problems because every time we would just take some value and try to assign it to some other thing, well, it wouldn't compile. Because, you can't pass client ID as a product ID. So we had a very positive experience with that. Although you need to deal with a bit of excessive bureaucracy in order to invest into that. So since Java 8, actually, we started realizing that Java that we can use types for representing different stuff. So, for example, types can be used for representing optionality. So whenever, instead of just returning a null pointer, you can wrap something in an optional and tell to the consumer of your method that, that's optional, okay, I need to handle that. And it doesn't only end at the level, you just don't end up with creating an object of your custom type. What's quite interesting is that if you design the API properly, you can try to encapsulate all this state, all this optionality, so that you don't need to worry about this all the time. So you put your value inside, you expose the API that worries about the optional context here, and then you pretty much interact with the value, and then at the end of the processing, you unpack the value, take it out, and handle the case if it was null or not. So basically, why not apply exactly the same approach to exception handling? It turns out we can, and that many languages are actually doing that. So we'll be talking now about a few different tools, but those are pretty common for different functional languages. We can find them also in many libraries. You can find it in Waver, you can find it in Cyclops, you can find it in Arrow for Kotlin, but today the examples will be based on Waver mostly. So, The first example that comes to mind, well, the try catching everything is very painful. So why not try to encapsulate into our own type? That would represent an operation that can fail or not. So it turns out tools like this are in Scala, for example. It's called a try. So it works kind of the same way as optional, but instead of encapsulating optionality, it encapsulates a method, some call that can produce an exception. What you can notice here is this sealed keyword. That's something new for Java, and I don't think they are even planning on introducing that. It allows you to restrict the type hierarchy. Okay, you can leverage finite algebra so that you can, for example, provide only 2 implementations of your interface, and people using those interfaces won't be able to add their own. It simplifies many things. Unfortunately, in Java, we don't have that. So we have this tool, and let's see how we could possibly use it. So let's take a very simple method. Let's take a method called getSearchResults that takes a string, returns a list of URLs, and throws an IO exception. So what could we do about that? Well, we can remove the throws IO exception clause and simply wrap our result in a try object. So everything becomes as simple as that. And now the cool part about this is that you are not forcing your consumers of your methods to process exceptions process it in this given way. I mean, if you throw an exception, well, if this is a checked exception, you need to try catch it and do something about that. But here, if you throw a try, you give a whole list of possibilities to user. They can still, bypass the try itself and come back to the, checked exception world if they really want to. They can leverage a bunch of different methods. So how would you normally interact with something like that? So you simply call the method. Okay, you pass in the string. And then, as you would be working with optionals or streams in Java 8, for example, you can interact using methods like map or filter. And the cool thing about this is that still you are operating within this encapsulated context. So if you pass a function to the map call, it will only be executed if the underlying, this thing that was encapsulated in a try was successful. Same with the filter. So and actual negative case scenario, you need to handle only at the end when you actually reach for the value that was inside. But that would be pretty boring if we could do only those things. So in this case, the APIs can be enriched a lot. And I don't really want to go through the whole API right now because, well, those tools can be found in different libraries. And, well, if you get the idea, you can do it by yourself. But still, let's have a look what we can find, for example, in Waiver. So, for example, API key is enriched with methods like onFailure. So you can continue your chain of execution, and then, for example, define that if something wrong happened, actually log that or perform some action passed as a Java consumer. Or maybe we know how to recover from certain exceptions. So, well, there's a method for that. And if we recover, obviously, since that point, it's no longer a failure because we recovered. So we are even come back to the successful scenario. And so on and so on. In this case, we can handle the default, we can provide the default value if something went wrong. 42 is usually a good option to return in such cases. So obviously, the API is much richer, but basically, that's the whole idea, but you can read the Java docs at home. What's also quite cool is that if you use those tools, they usually compose quite easily, not only on the consumer side, but also from the producer side, okay? Producer side means when you actually put some value inside and return to someone. So let's try to implement the body of the getSearchResult method. So now we'll be using for that two other methods. We'll be leveraging get from Google And as you can see, it returned, and it can throw two types of exceptions. It can throw no such element exception and IO exception. Also, the other method we will be falling back to is get from DuckDuckGo if something goes wrong with the first one. As you can see, those signatures vary a bit. Okay, they return different types of exceptions, and let's see how we can handle that on the producer side. So, in the first look, it might look quite scary, but if you let's go over it line by line. So what we are doing initially here, in the first line, we are creating a try object, initializing it with a function that returns results get from Google. But since the method is not very convenient to use because it throws different types of exceptions, we need to handle that somehow. So the first type of exception that method returns is no such element exception. And what does it mean? Okay, it means that element was not found. So why bother and throw an exception in such case? So let's recover from that. Let's recover from no such element exception and return an empty list instead. Additionally, by going into the source code, we discovered that there are some runtime exceptions from like NSA forbidden exception. Well, then we need to recover from that as well. And if still something went wrong, then we can fall back into get from DuckDuckGo, as you can see in the last line. Also, at some point, when you start composing all those different things together, at some point you will end up with nested structures, with kind of matryoshka thing, like optionals of optionals, try from tries. Whenever you end up with something like this, remember that there's a dedicated map method called flatmap for dealing with such cases. Also, what's quite cool is that if your language has pattern matching, you can also leverage that for dealing with such structures quite often. What's good is that apparently there will be pattern matching coming to Java. We don't know when yet, but it's on the roadmap somewhere. So, another option. It's an option. So, basically, in some cases, we actually don't need any super special tools for exception handling because we can avoid throwing them at all. So option can be used as well whenever you need to represent empty result or optionality, and you don't really care about particular results. So let's have a look at those examples. So you have two methods. You have find one and value of. Find one method throws no such element exception, as in our case with get search results. But do we really need to throw an exception here and kind of force your users to handle them in such a way? I mean, the exception itself won't probably tell you much, okay? Because you already have an ID of your person, and there's no point in that. So why restrict users to do it this way? Instead, well, for example, you could use try. Right? A little bit better, but still try is really good for handling cases where you have actually some exceptions, meaningful exceptions happening underneath. But there is nothing meaningful happening. So why bother at all? In such cases, we can often simply deal with by returning optionals. And that's all. It works pretty fine. What's actually quite scary is that if you go to GitHub and do some naive searches, you will see that there is quite a lot of abuse around the time. And imagine how easier would it be if, well, we were not forced to try catch all of those. So, but this is like the Scala way. But let's step back for a second, and if the exception handling in Go, well, was cool, let's try to simulate that in Java. So the simplest way to simulate this would be to use a tuple. So instead of, this is basically the only way that you can return two values from a function in Java. But here, as you can see, it doesn't look very, very cool, okay? Because in Go, at least, you would need to go for one null check. But here, you need to go even for two. The problem with that is the tuples work quite fine if you're working with non-nullable types objects. But here, unfortunately, it doesn't look very cool. But we can do better. So the ultimate, like the purest solution of all of them to exception handling is the use of either. Try is very good for Java, but still it's a kind of a form of a glue between what we find in Java and the functional world, because underneath it's actually doing a try catch, and those exceptions are still happening. So it's not really pure. But in this approach, we can avoid using exceptions at all. So the idea of either is that we have a type that can hold two different types, usually as a type representing a success case and another type representing a failure. And what's cool about that is that there is no throwing involved and that you can return your own objects, error objects, without expensive stack trace creations and so on. And if you think about this for a second, you will see that try actually is a form of either, very specified one, that always holds a throwable on one side. The cool thing about either is that it's unbiased, mostly. So, because if you work with optionals, you know, they can be empty, not empty, and they are biased towards non-emptiness. So if you call a method like map filter, it will work only if the optional is full. Same with try. It's biased toward the success. Those methods will work only if everything went fine. But either is a very generic purpose tool. Okay, it can hold two different objects, two different types inside. So in some languages, it won't be biased at all. But in Scala and Waiver, now it's biased towards the right side. So if you try, there is nothing fancy in instantiation of eithers, okay, because there is not that much context you can work on. So basically, you can manually only create left or right side and pass it as an either to your consumer of your API. And now here comes the trickiest part, because eithers are unbiased, can be unbiased. So how do we actually, work with either right or left side? This is where the very important concept of projections kicks in. So whenever you want to work on the left side of the either, you need to create a left projection. And whenever you call a map filter, it will behave as it will only act about those values if there was a left value in either. And same the other way around. If you go for the right projection, it will maps filters and all methods will act only if the either was actually right. So whenever you want to work with either, first you need to have some error objects. In Scala, it's as easy as creating a one-liner. Sorry. So basically, such thing can be like a fetch error. It can hold, for example, a string with a message and HTTP response in our case. But we are not in Scala. We are in Java. So we need to write a bit of more code to achieve the same stuff. That's actually 44 Scala case classes in there. That's a lot. But don't worry about that. Data classes are coming to Java soon as well. So how does it look like in action? So let's take our previous example of get search results that returns try with the list of URLs. And let's try to rewrite it using an either. So in such case, as you can see now, we are getting quite a lot of types in there. So we simply return an either that can hold either a fetch error or a list of URLs. And now, we call the method, and now, let's say we want to process results and errors separately. So if we want to process the right side and get list of URLs, we start by doing the right projection. We do a right projection, then do whatever we want with the API. Unfortunately, it's not that rich as, for example, tries or optionals, because there's not that much of a context here. You have only two values. So API is quite easy to follow. So you can call filters, maps, and so on, and then handle the default case scenario. But whenever you are interested only in errors, you go for the left projection and then interact with it in the same way you would with the other side. What's quite interesting is that try obviously can also be used as a, for example, tool that can help you manage to deal with alternative paths in your business logic. So imagine, for example, you're writing, let's say, DNS resolver, some internal method over there. So what happens over there? It can either give you a result or go and go to another DNS. So in such case, you could return an either, returning either a DNS URL or URL of your or resolved URL of what you passed in there. Actually, if you start digging into the Scala code, you'll see quite a lot of interesting either applications in there. So for example, if you look at the tail recursion is implemented using either in there. So as you can see, it's not that abstract idea. It can be used in many interesting scenarios. And now here comes an important thing. So what if your language doesn't support that? Well, obviously you can write that yourself. And we actually would do that like 4 years ago when Java 8 was released, when Waiver wasn't out there. But now we have tools, a lot of them, like Waiver, Cyclops, so we can pull them in our projects. My personal favorite is a Waiver because it follows Scala's conventions as much as possible. So this is pretty handy. If you've been working with Scala and you will jump into Java and start using Waiver, you will be only, well, a bit disappointed, not disappointed very much. Obviously, another way that you can do is try to become a part of the JCP, Java community process. Because as you might not know, many ideas in Java, well, all ideas in Java are pushed through the community. So for example, the fact that we have Java time is a result of community being unhappy with Java util date and pushing to implement new API that resembles Yoda time. I think same was with the project Lambda, because Mark Reinhold would say from quite often that Java will never get Lambda expressions. But then the project Lambda happens and they pushed it into Java. So whenever you want more tools like this, you can still become a part of that. Or if you don't want to, you can still catch some Java champions and try to push them to do this. We have quite a few of them today on the conference. So when it comes to the whole today talk, what I would like you to remember about is that, well, exceptions are not that bad. Of course, we're focusing on the bad sides of them, but they are not that bad. They have their use cases. But if you are not really happy with them, you can still use try, where you can replace try catches and use that to represent actions that can throw exceptions or not, and give a very nice alternative, elastic alternative for your consumers of your APIs to interact with that. But whenever you are dealing with simple absence modeling, why actually bother and force people to use exceptions? Remember that maybe sometimes it's better to step back and ditch exceptions and simply return an option instead. No need to force people to do anything. But for some very advanced, like custom scenarios, either will be great. But there's one problem with that. Because we are in Java, we depend often on many external libraries that throw exceptions. So if you would really try to be very pure regarding exception handling, that would be very hard, because you would need to kind of try to hide everything behind facades, and this is not very practical. Honestly, every time in every Java project, whenever we were trying to use eithers, it didn't work very well, if we really wanted to be like very strict about that. But tries worked really well. By using tries, you can encapsulate exception handling that's already there. Whenever you have a method that throws exception, you can easily wrap it and push it further. So probably either it's quite hard to incorporate, in some practical real-life projects, but try is very easy. You can start it using anytime you wish, without doing any major redesigns, rewriting all your exceptions to your error objects, and so on. Another thing is that I would like to remember that there is a library called Waiver that brings a lot of functional goodies to Java. What's really cool to see that when this library was introduced 4 years ago, everything was super fresh and super necessary. But all those ideas are slowly being pulled into Java, which means that the library over time will be getting smaller and smaller. This is the case, for example, with pattern matching. So this is a very nice trend to see in Java. I'm super interested which way will it go further. And actually the most important note for today is that you need to remember to use a common sense as your best practice. I remember I was giving a talk in France, I think it was France, and I got feedback the next day after the conference, and someone wrote that liked presentation very much and is already trying to rewrite the project at work and remove all exceptions. No, slow down, evaluate if this is useful for a particular case scenario, because if you go kind of too far away with that, you end up with crazy stuff like this one. So I guess it would be all for now. I hope that I managed to inspire you to have a look at the kind of old thing, the old dusty exception handling with a new approach. And thank you very much. We have some time for questions.
Hello. Hi, thanks for the presentation. So what is the effect on performance and optimization when you do this static typing and wrap all your longs in special types or all your string in special types?
That's a very good question, because obviously there will be impact on performance, because every time you create more complex hierarchies, you create more objects, you instantiate more objects, it will cost something, obviously. But me personally, whenever I go for mutability and try to ditch the defensive programming, is when actually I'm forced to. So on the everyday scenario, when we are doing like integration project or something, performance is often not a problem. So whenever I identify some problem, then I dig into and then I apply optimizations as like mutability or ditching ideas like this. But obviously, the more objects you produce, the more complex hierarchies are out there. It will be more impact on GC, the allocation objects, costs. If you have complex hierarchies, then you have those megamorphic call sites, which are costly as well. So there is some, but don't bother with that as long you don't really need to.
Okay, so maybe me. I very like this Scala-like approach, but in Scala, the types like try and either are native, and don't you feel that it doesn't make sense to push the consumers of our API to use third-party types like try or either?
Well, that's a problem, okay, since obviously in Scala embraces those ideas since the beginning, okay? As you can see, iders and tries, you can be found in the source code of Scala itself, so it's obviously there. So yes, obviously, introduction of every library to your code base is potentially a tech debt. So obviously, you need to evaluate it for your own needs. I personally, if I'm talking about Waiver library, it's production ready for quite a long time and quite stable and developed really serious. I was quite close to the development team for some time. So yes, this is something worth considering, very good question. But personally, I don't mind throwing and using them. But yes, obviously, this is, if you want to have better Java experience in general, you need to do that. You don't have any other option, or you just try catch everything.
Just a question, if you worked with Kotlin and nullable types, which basically now I have a problem with Kotlin. Should I use option, or nullable?
That's a super
type?
question. The question was about nullable types in Kotlin. And for those of you that you have no idea, Kotlin has a very special way of handling, its own approach to nullability. They didn't re-implement the idea of option in Kotlin. They have all types in Kotlin can be nullable or not. So all types by default are not. And compiler can leverage that. So for example, if you are working with a nullable type, you can't directly call it without checking if it's nullable or not. This is quite a different approach. What's quite interesting is that I like it. I personally like it a lot because it doesn't introduce a lot of unnecessary bureaucracy. Because here, if you are creating optionals, tries, sometimes you need to compose them together. So you have optionals of tries, tries of optionals, and then you might want to add another layer of abstraction. And for example, if you have a normal, let's say type T, and an optional of type T, you can't assign optional of type T to T and then the other way around whenever it makes sense. But you can do that in Kotlin. So yeah, that's also my problem as well. But I really like the way Kotlin took, because it shows that you can leverage all those ideas, but without paying the price of the excessive bureaucracy introduced by new types.
Any more questions? Probably not.
Okay, thank you very much.